All right, this is a video on standard form of a quadratic function, and we'll start off with a summary and some introduction, and then solve a couple examples for you. So to summarize, standard form of a quadratic function is as follows. Y equals ax squared plus bx plus c, following that standard form of a polynomial. Okay? And a, b, and c will be coefficients in an actual function that we'll be looking at. And x and y, of course, are our independent and dependent variables. A parabola can open upwards versus downwards. In the picture you can see, the graph you can see, the black parabola is opening upwards and the red parabola is opening downwards. And that's all based on what the a value is. So if a is greater than 0, we have an upward parabola. If a is less than 0, we have a downward parabola. The axis of symmetry is a vertical line that goes through the vertex. And so I will draw that here for the red parabola, and then I will highlight it as well to make sure it's easy to see and clear. So this yellow highlighted black line is the axis of symmetry. It's the vertical line that goes through the vertex. It has an equation. X equals negative b over 2a. And that came from a real place. It came from completing the square ultimately and solving for the x-intercepts of the parabola is one way of determining what this equation is. But regardless, just know it came from a real place. It has an x equals form because it's a vertical line. All vertical lines have the form x equal a number. And hopefully you can see that the negative b over 2a will be a number once we plug in the coefficients from the equation into that little formula. So this little formula is something that you just want to memorize, okay? You just want to make sure you have it handy. Definitely get it in your notes, but it's just something that you need to know. So the vertex form, or excuse me, the vertex of the parabola has a specific set of coordinates, and the coordinates will be as follows. Negative b over 2a, comma, f of h. And let me talk about what that means. So we use the letters h and k to refer to the vertex, the coordinates of the vertex of the parabola. Okay? H and k are not values within the equation, but we can determine them from coefficients in the equation. Okay? So to find the x-coordinate of the vertex, also known as h, we just use that little formula negative b over 2a. Okay? And hopefully that makes sense because that's the x value that the axis of symmetry is going through, right? The x value upon which the axis of symmetry lies. And then to find the k-coordinate of the vertex, so this is the h-coordinate, we use a little formula, negative b over 2a. To find the k-coordinate, we just need to plug in h back into our function to see what k is. So that's what f of h means. Presumably we're dealing with a function f of x equals ax squared plus bx plus c. So back up here, instead of, for standard form, instead of saying y equals ax squared plus bx plus c, we could also say f of x is ax squared plus bx plus c. So to find the k value, which I'm highlighting in yellow right now, we just need to plug our h value back into the equation to see what we get as an output. It's the most complex piece of things. Y-intercept is easy. The y-intercept is always just c. Okay? Equals c. So whatever the c value is in our standard form equation, that is equal to the y-intercept. Because when you are looking for the y-intercept, you're looking for the value of y when x is 0. And when we plug x into our equation, the first two terms would disappear, and we're left with just y equals c. All right, let's do a couple examples. So let's determine the vertex, axis of symmetry, range, and y-intercept of the function. Okay, so the vertex, we're going to first use negative b over 2a. But before we do that, I really like to simply write out what a, b, and c are. Okay, so to find the vertex, in other words, to find the h portion of the vertex first, we'll do negative b over 2a, which is negative 6 over 2 times negative 2. Negative b over 2 times a. Okay? And so that's 6 over 4, which is 1.5. So that's h. That's the x-coordinate of my vertex. Now to find k, we just need to plug h into our equation and solve from there. And I'm just going to run that through my calculator real quick to get a solution for k. And I get a negative 0.5 for k. So that's telling me that the coordinates of my vertex are 1.5 comma negative 0.5. Okay, so we got the vertex. The axis of symmetry is just a vertical line that goes through the vertex. So the axis of symmetry, I'll abbreviate that as A of S, is just x equals whatever our h value is. Okay, 1.5. The range is the set of y values that are eligible to be graphed in this function, in this parabola. What could y possibly be? So this is a parabola that opens down. So I'll just do a very rough sketch here. This is a parabola that opens down from a vertex of 1.5 comma negative 0.5. So very roughly we have a parabola that looks like that. And so it's telling me, that sketch is telling me that y could be negative 1.5 or below. So in other words, any y values are going to be down in that downward direction from the vertex. So the range, we're just going to say y is less than or equal to, excuse me, I think I misspoke. Y is less than or equal to negative 0.5, okay? So the highest y could be is this negative 0.5 value. So y will be less than or equal to negative 0.5. Okay, anything negative 0.5 and below. So that's our range right there. We got that. And lastly, the y-intercept. Okay, so the y-intercept is simply equal to c. Okay, so the y-intercept is over 0 comma negative 5, down 5. I just used the c value to get that. Every y-intercept has an x-coordinate of 0, and then here we have a y-coordinate of negative 5. All right, let's do one where we're actually tasked with graphing it. So y equals, or f of x equals 3x squared plus 6x minus 2. And so I like to find the vertex first. And so let's find h first, which is negative b over 2 times a, which is going to equal negative 1. Okay? And now we need to find the k value of our vertex. In other words, let's plug negative 1 into our equation and see what we get. 3 times negative 1 squared plus 6 times negative 1 minus 2. This is 3 times 1 minus 6 minus 2, which is negative 5. So k is equal to negative 5. So my vertex is at negative 1 comma negative 5. So I'll plot that right there. Okay. Next, what I like to do is find my y-intercept. Okay, and my y-intercept is going to be negative 2. And so I can plot that one up right here. And then from that, I can use symmetry. I know that there will be what I call a partner point on the opposite side of my axis of symmetry, which will also be at negative 2, having a y value of negative 2. So we can plot our parabola. It's a pretty skinny parabola, and that makes sense because the a value is larger than 1. A value is 3, and so we vertically stretched my parabola. So I would argue that 3 points are the minimum needed to graph a parabola, especially if one's the vertex, you need at least a couple more. If you don't have the vertex, I would want to see more than 3 points, and at least a couple points on either side of the vertex. All right, and lastly, we can take standard form and we can convert it to vertex form. Okay, so we did vertex form in a prior video, and let's go ahead and take this standard form example and simply convert it to vertex form. We already know what a is. Vertex form needs a, and so we already know that a is negative 1.5, so that's a good start. But we need to find h and k. We need to find the vertex of the parabola, so we can plug things into vertex form, which I'm writing right here. So we found A. Now let's find h and k. So just recall, h is negative b. Now, and for this one, I'll write down what a, b, and c are. Okay, so h is going to be negative b, negative of negative 6, all over 2a. Okay, don't try to do too much in your head. At least I'm liable to make mistakes, so I encourage you to write down as much of your work as you can. 6 over negative 3. So it looks like my h value is a negative 2. Okay, we're going to take that negative 2 and plug it in for x into our function to see what the y coordinate of my vertex is, to find what k is. So k is going to equal negative 1.5 times negative 2 squared minus 6 times negative 2 plus 18. Okay, so let's just gradually simplify step by step. Negative 1.5 times 4 plus 12 plus 18. Negative 1.5 times 4 is negative 6 plus 30. So k is equal to negative 24. All right, so we have our a value, we have our h value, we have our k value. We can plug it all into vertex form. Negative 1.5 times x minus our h value, which is negative 2. So I can call that an x plus 2 squared plus a negative 24. Okay, so these two functions that I'm highlighting in red should be the exact same function. They are just in different form. Okay, but they would have the exact same graph, the exact same function. They just look different because they're in a different form. All right, we did it. Good place to stop.